Learning objectives. At the end of this topic, you will be able to define congruence of triangles, understand the criteria for the congruence of two triangles, learn properties of a triangle, solve problems based on the properties of an isosceles triangle, identify the theorems on inequalities of a triangle, apply the theorems to solve problems involving inequalities of triangle. Introduction. What are congruent triangles? Consider two triangles ABC and EFG, such that the corresponding angles are equal and corresponding sides of both the triangles are equal. The sides of the triangles ABC coincides with the side of a triangle EFG. The angles of the triangle ABC exactly cover the angles of the triangle EFG. So we can say these two triangles are congruent and denoted by the symbol. Here the tilde symbol represents the same in shape and the equal symbol represents the triangle are same in size. In general, two triangles are congruent. They will have exactly the same three sides and exactly the same three angles. Congruence of triangle. Congruent means identical or same or exact, etc. Here we compare the shapes. Then we find they are congruent or not congruent. Let's draw two shapes, triangle and rectangle. Is triangle exactly covering the rectangle? Or is the rectangle exactly covering the triangle? No. The two shapes coincide with each other. We say they are congruent, else they are not congruent. Again, we consider the two triangles. Triangle ABC is congruent to triangle EFG. Is also A corresponds to E, C corresponds to G. For any two congruent triangles, the corresponding parts are equal. And if it's termed corresponding parts of congruent triangles or Cpct. Based on the above discussion, triangle ABC is congruent to triangle EFG, but triangle ABC is not congruent to triangle FGH. Criteria for congruence of triangles. Two triangles are defined based on different criteria. We know that two triangles are congruent if all the six parts of one triangle are equal to the corresponding six parts of the other triangle. We can also prove two triangles are congruent even if the three parts of one triangle is equal to the corresponding parts of the other triangle. We'll discuss the basic criteria that states two triangles are congruent. Let's start with side-angle-side congruence rule. Two triangles are congruent if two sides and the included angle of one triangle are equal to the two sides and the included angle of the other triangle. This criterion is referred to as side-angle-side, SAS rule. Consider triangle ABC and EFG such that side AB is equal to side EF, side BC is equal to side FG, and angle B is equal to angle F. Then triangle ABC is congruent to triangle EFG. It's true for the congruence triangle if they're corresponding to two sides and the included angles are equal. So it is accepted true, an axiom. Let's see a few examples here. In the adjoining quadrilateral, AC is equal to AD and AB bisects angle A. Show that triangle ABC is congruent to triangle ABD. What can you say about BC and BD? As AB bisects angle A, angle CAB is equal to angle DAB. In triangle ABC and triangle ABD, AC is equal to AD, it is given, and AB is equal to AB, since it is a common side for both the triangles ABC and ABD. Angle CAB is equal to angle ABD, since AB bisects angle A. Therefore, triangle ABC is congruent to triangle ABD by Sas Axiom of Congruency. Therefore, BC is equal to BD by Cpct Theorem. Consider the next example. AB is a line segment and line L is its perpendicular bisector. If P is a point on L, show that P is equidistant from A and B. Given L is perpendicular bisector of AB and P is a point on L, so M is a midpoint of AB and MP is perpendicular to AB. In triangle AMP and BMP, AM is equal to MB since M is a midpoint of AB. MP is equal to MP. Angle AMP is equal to angle BMF since each angle is equal to 90 degree. Therefore, triangle AMP is congruent to triangle BMP by Sas Axiom of congruency. Therefore, AP is equal to BP. This implies P is equidistant from A and B by Cpct Theorem. The second congruence rule states that two triangles are congruent if two angles and the included side of one triangle are equal to two angles and the included side of the other triangle. This is referred to as angle-side-angle for Aas Congruence Rule. Let's prove the theorem. Consider two triangles ABC and EFG. Angle B is equal to angle F. Angle C is equal to angle G. And BC is equal to FG. To prove these triangles are congruent, we use the Sas Congruence Rule. For proving the congruence of the two triangles, the following three cases arise. Let's prove the first case. AB is equal to EF. In triangle ABC and EFG, we see AB is equal to EF, angle B is equal to angle F, and BC is equal to FG. This satisfies the Sas Congruence Rule. Therefore, triangle ABC is congruent to triangle DEF. In the second case, let's assume AB is greater than EF. So we can take a point P on AB such that PB is equal to EF. Now in triangles PBC and EFG, we observe PB is equal to EF, angle B is equal to angle F, and BC is equal to FG. Thus, by the Sas axiom, we conclude triangle PBC is congruent to triangle EFG. Since the triangles are congruent, their corresponding parts will be equal. Thus, angle PCB is equal to angle EGF. But we are given that angle ACB is equal to angle EGF. So, angle ACB is equal to PCB. This is possible only if P coincides with A or BA is equal to FE. But we have assumed PB is equal to EF. This implies AB is equal to EF. Also, angle B is equal to angle F and BC is equal to FG. Therefore, by Sas axiom, triangle ABC is congruent to triangle EFG. In the third case, consider AB is less than EF. In this case, consider a point Q on EF such that QF is equal to AB. Proceeding in the same way as we did in case 2, we can conclude that QF is equal to EF. Therefore, by Sas Congruence Rule, triangle ABC is congruent to triangle EFG. We know the sum of three angles of the triangle is 180 degrees. If two angles of one triangle are equal to the corresponding two angles of another triangle, then the third angle of both the triangles will also be equal. Thus, instead of included side, we may have any pair of corresponding sides as equal. Thus, the Aas Congruence Rule is sometimes referred to as AAS or SAA Congruence Rule. Consider the example. In the adjoining figure, AD and BC are equal perpendiculars to a line segment AB. Show that CD bisects AB. In triangles OBC and OAD, BC is equal to AD, angle OBC is equal to angle OAD, since each angle is equal to 90 degrees, and angle BOC is equal to angle AOD, since they are vertically opposite angles. Thus, by Sas rule of congruency, triangle OBC is congruent to triangle OAD. Therefore, OB is equal to OA by Cpct Theorem. This implies CD bisects AB. Properties of triangle. Consider a triangle in which two sides are equal, say each equal to 5 centimeters, and the third side is equal to 3 centimeters. Can you determine its type? We can see that two of its sides are equal. A triangle in which two sides are equal is called an isosceles triangle. The third side becomes the base of an isosceles triangle. Now let's join the vertex to the base of the triangle. If we fold the triangle along this line, it divides the triangle into two equal wide-angle triangles. As you can see, the corresponding sides and angles of these two triangles are equal. Coming back to the isosceles triangle, we have two equal sides and the angles opposite to the sides are also equal. Based on these observations, we can conclude that angles opposite to the equal sides of an isosceles triangle are equal. Let's prove two important theorems of isosceles triangle. Angles opposite to equal sides of an isosceles triangle are equal. Consider an isosceles triangle ABC, in which AB is equal to AC. We need to prove that angle B is equal to angle C. Angle B is opposite to side AC. Angle C is opposite to side AB. Let's draw a bisector of angle BAC meeting BC at D. First, we'll show triangle ABD is a congruent triangle to ACD. In triangle ABD and triangle ACD, AB is equal to AC. This is because triangle ABC is an isosceles triangle. Angle BAD is equal to angle CAD. Since AD is the bisector of angle A, side AD is common to both the triangles. Now by Sas Axiom, if two sides and included angle of one triangle are equal to the two sides and included angle of the other triangle, then the triangles are congruent. Thus, triangle ABD is congruent to triangle ACD, and since the corresponding parts of the congruent triangles are equal, therefore, angle B is equal to angle C. The converse of the above theorem is also true. That is, the sides opposite to equal angles of a triangle are equal. Let ABC be the given triangle in which angle B is equal to angle C. We need to prove that side AB is equal to side AC, which are the sides opposite to the equal angles. Like we did in the previous proof, here too we will draw a bisector from the vertex to the base. This divides the triangle into two triangles. Then using the criteria of congruence, we'll prove that the resulting two triangles are congruent. Then using Cpct, which implies corresponding sides are equal, we'll prove the converse theorem. Let's draw bisector AD of angle BAC meeting BC at D. Thus two triangles ABD and ACD are obtained. In triangle ABD and triangle ACD, we are given that angle B is equal to angle C. Angle BAD is equal to angle CAD. Since AD is a bisector of angle A, and side AD is common to both the triangles. Now, as we know by the Aas criterion, if two angles and one side of one triangle equals two angles and one side of the other triangle, then the two triangles are congruent. Thus, triangle ABD is congruent to triangle ACD, and since the corresponding parts of the congruent triangles are equal, side AB is equal to side AC. Here we see a few examples of properties of triangles. ABC is an isosceles triangle in which BE and CF are altitudes drawn to equal sides, AB and AC. Show that these altitudes are equal. In triangle ABC, AB is equal to AC. BE is perpendicular to AC. CF is perpendicular to AB. We need to prove BE is equal to CF. In triangle ABC, AB is equal to AC. This implies angle ACB is equal to angle ABC. In triangle BCE and triangle CBF, angle ACB is equal to angle ABC. Angle BEC is equal to angle CFB. BC is equal to BC. Thus, by Aas Congruence Rule, triangle BCE is congruent to triangle CBF. Therefore, BE is equal to CF. Consider the next example. In the given figure, AD is equal to AE, BD is equal to EC. Prove AB is equal to AC. Given AD is equal to AE, BD is equal to EC. We need to prove AB is equal to AC. BD is equal to EC. Adding DE on both sides, we get BD plus DE is equal to EC plus DE. BD plus DE can be written as BE. Similarly, EC plus DE can also be written as DC. In triangle ADE, AD is equal to AE. This implies angle 1 is equal to angle 2, since angle opposite to equal sides are equal. In triangle AEB and triangle ADC, AE is equal to AD. Angle 1 is equal to angle 2. BE is equal to DC. It's already proved in equation A. By ASA, triangle AEB is congruent to ADC. Thus, by Cpct theorem, implies that AB is equal to AC. Some more properties of congruence triangle. If three sides of one triangle are equal to the three sides of another triangle, then the two triangles are congruent. This is referred to as the side-side-side or Sss Congruence Rule. This can be proved by construction. Consider triangle ABC. We now construct triangle EFG by using the sides of triangle ABC. On comparing, we see the respective sides are equal. Therefore, the triangles are congruent. If in two right triangles the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. This is referred to as the right angle hypotenuse side or RHS Congruence Rule. This rule is applicable to any of the right angle triangles. As you have seen, we say two triangles are congruent if at least three parts of one triangle are equal to the corresponding three parts of the other triangle. But this is not always true. For example, SSA or side-side angle, ASS or angle side-side, and AAA or angle-angle-angle are not sufficient to prove the congruence of two triangles. Let's look at some examples to understand it better. Consider two triangles ABC and EFG, where AB is equal to EF, BC is equal to FG, angle C is equal to angle A. Can you superimpose these triangles? This is not possible. Hence, the triangles are not congruent. Therefore, side angle criterion does not hold true. Now let's take an example to examine AAA criteria. Let's look at the triangles. In these, the corresponding angles are equal. Here, the sides of one triangle are not equal to the sides of the other triangle. Therefore, these triangles are not congruent. AB is a line segment. P and Q are points on opposite sides of AB, such that each of them is equidistant from the points A and B. Show that the line PQ is a perpendicular bisector of AB. Given PA is equal to PB and QA is equal to QB, we need to prove that PQ is perpendicular to AB and PQ bisects AB. Let PQ intersect AB at C. Can you determine two congruent triangles in this figure? Yes, in these triangles AP is equal to BP, AQ is equal to BQ. PQ is the common side of the two triangles, so PQ is equal to PQ. Thus, by SAS rule, triangle PAQ is congruent to triangle PBQ. Therefore, angle APQ is equal to angle BPQ by Cpct theorem. Now consider triangle PAC and triangle PBC. In these triangles, AP is equal to BP, angle APC is equal to angle BPC. Since angle APQ is equal to angle BPQ, we have already proved the above. Here, PC is the common side of triangle PAC and triangle PBC. So, triangle PAC is congruent to triangle PBC. Therefore, by Cpct theorem, AC is equal to BC. Consider this as equation 1. Angle ACP is equal to angle BCP. Also, by linear pair, angle ACP plus angle BCP is equal to 180 degrees. This we can write it as 2 times of angle ACP is equal to 180 degrees. This implies angle ACP is equal to 90 degrees. Consider this as equation 2. From 1 and 2, you can easily conclude PQ is the perpendicular bisector of AB. P is a point equidistant from two lines L and M intersecting at point A. Show that the line AP bisects the angle between them. Given that lines L and M intersect each other at A. Let PB be perpendicular to L, PC is perpendicular to M. It is given that PB is equal to PC. We have to show that angle PAB is equal to angle PAC. Let us consider triangle PAB and triangle PAC. In these two triangles, PB is equal to PC, angle PBA is equal to PCA, is equal to 90 degrees. PA is equal to PA, since it is a common side. So by RHS rule, triangle PAB is congruent to triangle PAC. Therefore, by using Cpct theorem, angle PAB is equal to angle PAC. Inequalities in a triangle. A triangle is formed by three intersecting lines. A triangle has three sides, three angles are included by the three sides. If we replace one side with a longer, the measure of three angles changes. This says the angles and length of the sides are proportional. Let's perform an activity to understand this better. Let's draw a triangle of length 6, 8 and 10 units respectively. What type of a triangle is this? Yes, it's a right-angled triangle. Let's name this triangle as ABC. Observe the triangle and its angles measured here. Let's experiment using this triangle. The length of 10 units is extended to the length of 11 units. Observe the angle C is fixed, but the angle B is increased. Let's repeat the experiment. We extend the length to 12 units and 13 units. What can you observe here? As we keep on increasing the length of one side, the angle opposite to that side increases proportionately. So we say the measure of the angle varies according to the side opposite to it. By using the observation, we can verify the following theorems. The first theorem states that if two sides of a triangle are unequal, the angle opposite to the longer side is larger. To understand this theorem, let's consider the triangle with the sides of 10 units, 8 units, and 6 units respectively. Of these, the 10-unit side is of the greatest length. Now compare the angles opposite to the 10-unit side and the 8-unit side. You can observe the angles opposite to the 10-unit side is greater. Similarly, you can verify the angle opposite to the 8 and 6-unit side. Children, as an exercise, you can verify the other triangles also. Now let's verify the second theorem. The theorem states that in any triangle, the side opposite to the larger angle is longer. Now let's verify this theorem using the first triangle. The greatest angle in this triangle is 90 degrees. You can verify that the side opposite to the greatest angle is the 10-unit side, which is the longest side among the three sides. As an exercise, you can verify this with other triangles also. The second theorem is the converse of the first theorem. Now let's learn about the other theorem. This theorem is about the sum of the sides of the triangle. The theorem states the sum of any two sides of a triangle is greater than the third side. To verify it, let's take the triangle with sides A, B, and C. Of the three of its sides, if we take any two sides at a time, the sum of two sides is greater than the third side. That is, A plus B is greater than C, B plus C is greater than A, and C plus A is greater than B. Let's verify this through an activity. We will use the same example we've used for the other theorems. Let's substitute the sides A, B, and C with 6, 8, and 10 respectively. If we consider two sticks at a time and add their lengths, we observe the following. Now let's try to construct a triangle with sticks of length 6, 8, and 14 units. Is it possible to construct a triangle with these sides? You can observe that it is impossible to form a triangle. Let's see why. On comparing, we find the sum of the two sides is equal to the third side. We cannot construct a triangle with such measurements. Similarly, we cannot construct a triangle if the sum of the two sides is less than the third side. Example: in triangle ABC, angle A is equal to 50 degrees, angle B is equal to 60 degrees. Arrange the sides of triangle ABC in ascending order. In triangle ABC, angle A plus angle B plus angle C is equal to 180 degrees. In this equation, substitute the angles for A and B. This implies 50 degree plus 60 degree plus angle C is equal to 180 degree. Solving this, we get angle C equal to 70 degrees. Since 50 degrees is less than 60 degrees less than 70 degrees, this implies BC is less than AC is less than AP. Summary. Let's summarize the topic. Two figures are congruent if they are of the same shape and of the same measure. Two circles of the same radii are congruent. Two squares of the same sides are congruent. If two triangles ABC and PQR are congruent, under the correspondence A tends to P, B tends to Q, and C tends to R, then symbolically it's expressed as triangle ABC approximately equal to triangle PQR. Sas Congruence Rule. If two sides and the included angle of one triangle are equal to two sides and the included angle of the other triangle, then the two triangles are congruent. Aas Congruence Rule. If two angles and the included side of one triangle are equal to two angles and the included side of the other triangle, then the two triangles are congruent. Aas Congruence Rule. If two angles and one side of one triangle are equal to two angles and the corresponding side of the other triangle, then the two triangles are congruent. Angles opposite to equal sides of a triangle are equal. Sides opposite to equal sides of a triangle are equal. Each angle of an equilateral triangle is 60 degrees. Sss Congruence Rule. If three sides of one triangle are equal to the three sides of the other triangle, then the two triangles are congruent. RHS Congruence Rule. If in two right triangles, hypotenuse and one side of a triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. A triangle has three sides and three angles. If two sides of a triangle are equal, then the angles opposite to them are also equal and vice versa. In a triangle, the angles and the lengths of the sides are proportional. If two sides of a triangle are unequal, the angle opposite to the longer side is greater. In any triangle, the side opposite to the larger angle is greater. The sum of any two sides of a triangle is greater than the third side. If A, B, and C are three sides of a triangle, then A plus B is greater than C. B plus C is greater than A. C plus A is greater than B.